Do you live in Japan? Do you live anywhere on the Pacific Rim, in South Korea, in Taiwan, in the Philippines, along the western coast of the United States? Do you rely on GPS navigation, on satellite communication, on power grids that hum quietly in the background of daily life? If the answer is yes to any of those questions, then what happened this week over Japan deserves your complete and undivided attention. Because, in a span of fewer than 72 hours, two completely separate forces, one born from the fury of the western Pacific Ocean and one arriving from 93 million miles away in outer space, converged directly over the same nation at the same time. A typhoon tore through Okinawa, smashed across Wakayama, flooded the streets of Tokyo, and knocked out power to 60,000 homes. And while Japan was still soaking wet and shaken, a Cannibal coronal mass ejection launched from the sun was racing toward Earth and pushing the planetary KP index towards 7. This is not a coincidence worth shrugging at. This is two systems arriving simultaneously, and experts are watching both very carefully tonight. Let us start at the bottom, at sea level, where Typhoon Jangmi, the sixth named storm of the 2026 Pacific typhoon season, first appeared over warm open water south of Okinawa. The Japan Meteorological Agency had been tracking it for days. It was not subtle. The storm moved northwest in late May, organizing quickly over water temperatures, warm enough to sustain a system with maximum sustained winds climbing toward 113 kilometers per hour, with gusts exceeding 145 kilometers per hour. By June 1st, more than 7,000 households in Okinawa had already lost power. 2 people had been taken to hospital after being knocked to the ground by wind gusts. The Japan Meteorological Agency issued warnings across Okinawa Prefecture telling residents, do not go outside, do not drive, prepare for life-threatening conditions. And here is the thing that most people watching international headlines missed. Jangmi was not staying in Okinawa. It was moving, methodically, purposefully, northeast. By June 2nd, the power outage count in Okinawa and Kagoshima prefectures had climbed to nearly 48,000 homes in the dark. Schools closed, businesses shuttered. The Japan Meteorological Agency issued warnings about violent winds, potential landslides, and flooding across a wide coastal zone. 16 people were injured. 15 buildings had taken partial structural damage, and still the storm moved north. Airlines began canceling flights across southern Japan. Highways flooded. Families who had been sleeping safely the night before woke up to roads that no longer looked like roads. But here's the problem. The storm was not weakening the way forecasters had initially hoped. When Jangmi made landfall in Wakayama Prefecture, on the main island of Honshu, just before dawn on June 3rd, it came ashore at 04:30 in the morning, Japan Standard Time. Most people in Wakayama were still asleep. The storm center came in with a central pressure of 980 to 985 hectopascals. That may sound like a number on a gauge to some viewers, but translating it into human terms is simple. It means wind. It means rain. It means the Koza River in Wakayama rose so fast and so violently that the Japan Meteorological Agency issued its highest level 5 flood emergency warning, the most extreme on the scale, for the first time since the country introduced its new 5-level warning system just weeks earlier in May 2026. The agency did not mince words. The official statement said, "It is extremely likely that some form of disaster has already occurred. This corresponds to alert level 5. There is an imminent danger to life, and people must take immediate action to ensure their safety." That is the Japanese government at 4 in the morning telling its citizens that survival, not preparation, is now the priority. And tonight changes the timeline when you understand what was happening in the sky above all of this at the exact same moment. 3 days earlier, on June 2nd and 3rd, a sunspot region on the face of the sun, designated Active Region 4455, or AR4455 by NASA and no AEA scientists, had begun erupting with extraordinary violence. This is not a region scientists take lightly. AR4455 had developed what experts call a beta-gamma configuration with anti-hail polarity distribution. What that means in plain English is that the magnetic fields inside this sunspot had twisted themselves into an unstable geometry capable of releasing enormous energy. And release it did. Within a single day, AR4455 fired off an M9, 3 solar flare, so close to the X-class threshold that instruments barely distinguish between the two. Then it fired an M7, 7 flare. Then it fired an X1, 0 flare. 3 massive eruptions from one sunspot region in less than 24 hours, each one launching a coronal mass ejection, a cloud of magnetized plasma, directly toward Earth. Most people are missing this. Not all 3 of those clouds were traveling at the same speed. When a faster CME catches a slower one in space, it does not simply pass it. It devours it. It engulfs it. The 2 clouds merge into one denser, more compressed, more energetically violent structure that scientists call a Cannibal CME. And that is exactly what happened here. The fastest cloud from AR4455, launched by the X1. 0 flare, overtook the earlier, slower-moving cloud from the M-class eruptions and absorbed it, creating a merged structure now racing toward Earth at extraordinary speed. NASA's Solar Dynamics Observatory captured the eruptions in real time. Coronagraph data from instruments monitoring the space between the Sun and Earth confirmed the merge. NOAA's Space Weather Prediction Center issued its response on June 3rd. A strong geomagnetic storm watch, G3 class, in effect for June 4th and June 5th, 2026. A G3 storm is not something you ignore. To understand what G3 means, consider the scale. The planetary KP index runs from 0 to 9. 0 is calm. 5 is the threshold for a geomagnetic storm. 7 is classified as G3, strong. At that level, power systems may require voltage corrections. Spacecraft operators lose partial control of surface charging. GPS navigation degrades or becomes intermittent, especially at high latitudes. High-frequency radio communications break down across wide regions. Satellites in low Earth orbit begin experiencing increased atmospheric drag that alters their trajectories, and the aurora borealis, the northern lights, becomes visible as far south as Illinois, Indiana, Pennsylvania, and potentially even further as the magnetosphere compresses under the pressure of the incoming solar plasma. Now the focus shifts to what makes this week different from any ordinary geomagnetic storm event. The Cannibal CME arrived. On June 5th, 2026, just 2 days after Japan had been battered by Jangmi at sea level, the merged solar plasma cloud hit Earth's magnetosphere. Forecasters from the Magnetic Storm Tracking Organization Pogodnik reported that activity peaked toward KP7, a G3 strong storm, with the strongest window centering on June 5th and linked directly to that series of eruptions from AR4455. The timing was not symbolic. It was simultaneous impact. A nation still counting its storm damage and still restoring power lines to tens of thousands of homes was sitting under a sky now lit by geomagnetic disturbance. And here is why this is serious. Not just as a news story, but as a pattern. Japan is one of the most technologically sophisticated nations on Earth. Tokyo is the world's most populous metropolitan area. It operates one of the most complex rail systems ever built. It relies on GPS timing signals for everything from train coordination to financial transactions. Suzuki Motor Corporation had already shut down all 5 of its Shizuoka prefecture plants during the typhoon on June 3rd. Rail lines across the Tokyo metropolitan area had been suspended. About 760 domestic flights and 90 international flights were canceled on a single day. Japan Airlines, All Nippon Airways, Skymark, Starflyer, all canceled Haneda Airport departures before noon. In Mie Prefecture, some areas recorded in a single day a rainfall total equivalent to an entire month of normal precipitation. And while that was happening at the surface, the sun was adding pressure from above. This next part matters because the infrastructure risk does not end when the typhoon passes. A G3 geomagnetic storm at the same time that a nation's power grid is already strained by storm damage creates a compounding scenario that emergency planners spend years trying to model and prevent. Think about what happens when a high-voltage transformer already stressed by wind and flooding is then subjected to geomagnetically induced currents, electrical surges created in the grid by the rapid fluctuation of Earth's magnetic field. These are not hypothetical risks. They are documented. During the March 1989 geomagnetic storm, a G5 event, the entire province of Quebec, Canada, lost power in under 90 seconds. 6 million people. No warning. No time to prepare. Transformers melted. It took 9 hours to restore partial service and weeks for full recovery. That was 1989. Japan in 2026 is wired far more tightly than Quebec was then. The total evacuation order in the Jangmi aftermath covered more than 6 million people across the Tokyo metropolitan area. Over 170,000 of those were from Hyogo Prefecture alone, nearly 112,000 from Chiba, more than 79,000 from Tokyo itself. Over 50,000 in Shizuoka were under evacuation orders. A convenience store in Shimoda, Shizuoka, was inundated after water levels rose dramatically in under 20 minutes. Employees said floodwater poured through gaps beneath the doors, and the timing coincided with high tide, leaving staff trapped and scrambling. A landslide in Kawazu sent mud and debris onto railway tracks near Imahama Kaigan Station. The Tama River in Kawasaki rose to levels that flooded the surrounding lowlands. A road intersection in Kawasaki's Saiwai ward went underwater. Floodwater near Kawasaki Station reached 30 centimeters in depth. Drivers found themselves on highways that had turned into rivers. At least 23 people were injured. 57 houses were damaged nationwide, and tens of thousands of families went to sleep that night without power, some without knowing whether their homes would still be standing in the morning. But that is not the real story. The real story is what AR4455 still has left in it. Scientists observing the sunspot region on June 4th and 5th noted that it had evolved into what is classified as a beta-gamma-delta magnetic configuration. Delta is the most dangerous classification in solar physics. It means the magnetic field lines inside the sunspot are so tangled, so compressed, and so unstable that the probability of another X-class flare is significantly elevated. Photographers in Sedona, Arizona, and Tucson, Arizona, amateur solar observers with hydrogen alpha filters, captured images of AR4455 and noted that the departing sunspots and complex field structure were still visible. NOAA's SWPC noted that if additional eruptions occur while the region still faces Earth, new CMEs could add to the current storm sequence, potentially escalating conditions beyond what the June 4th to 5th watch predicted. And there is still more incoming. Space weather analysts tracking the solar rotation cycle have identified a second active period expected around June 11th and 12th, with KP6 conditions possible on the 11th. That means G2 moderate storm conditions could follow the G3 peak in less than a week. After that, a third potential active window opens in the June 23rd through 27th range. Solar cycle 25, the current 11-year cycle, is at or near its maximum. That means the sun is producing more active regions, more flares, and more CMEs than at any point since the previous solar maximum over a decade ago. What happened next changed everything about how forecasters are thinking about this region. The 2003 Halloween solar storms remain the benchmark that space weather scientists return to again and again. On October 28th and 29th of 2003, a series of X-class flares, including an X17 and an X10, launched CMEs that struck Earth and drove the KP index to a sustained 9, a G5 extreme event. Power grids failed across Sweden. Transformers were permanently destroyed in South Africa. 50 satellites experienced operational anomalies. Airlines rerouted polar flights to avoid radiation exposure. The aurora borealis was seen from Texas, Florida, and Japan. The total economic disruption ran into billions of dollars, and the solar activity driving those storms came from a single hyperactive sunspot region that, by some metrics, bears structural similarities to what AR4455 displayed this week. The comparison is not alarmist, it is instructive. AR4455 produced an M9, 3 an M7, 7 and an X1, 0 in under 24 hours. The Halloween 2003 sequence produced X17 and X10 events. The current event is not at that level, but the mechanism, a single beta gamma delta active region repeatedly erupting while Earth-facing, is the same. And the lesson from 2003 is that these regions do not always fire their biggest shots first. Sometimes the largest eruption comes after the initial sequence, when the magnetic field lines have been partially disrupted and the instability increases rather than decreases. This is where it becomes dangerous. AR445 was still Earth-facing as of June 5th and 6th. On the ground in Japan, the human cost of Jangmi continued to accumulate even after the storm center had moved northeast of Narita Airport and begun transitioning into an extratropical cyclone. Reports of flooding, fallen trees, and debris were coming in across a wide swathe of the country. Postal services in Tokyo and 13 other prefectures were suspended. East Japan Railway Company suspended several major lines from the start of service on June 3rd. The Tokyo Metropolitan Government issued its first ever Level 4 danger alert under the country's new weather warning system, a milestone no one wanted to achieve. In Hyogo, residents reported roof damage from wind gusts. In Kawasaki, people commuted through rain so heavy that visibility dropped to near zero. Workers at manufacturing plants across Shizuoka went home because the buildings could not operate safely in those conditions. And while all of that was happening, the KP index was climbing. One more thing you need to know. GPS degradation during a G3 storm is not a minor inconvenience for a country dealing with an active disaster response. Emergency responders in Japan rely on GPS positioning for flood mapping, rescue coordination, and evacuation routing. Satellite navigation systems used by Coast Guard vessels monitoring swollen river mouths are subject to degradation at KP7. Radio communications used by emergency management teams operating in areas without cellular coverage are affected by high-frequency radio blackouts that a G3 storm generates. These systems do not simply work slightly less well. They can fail entirely in the worst moments of a response operation. The overlap between storm damage and space weather pressure is not just an interesting news story. It is a genuine operational risk to the people trying to help. The families who evacuated from Tokyo's low-lying river zones, 79,000 of them in the capital alone, went to evacuation centers that themselves depend on power infrastructure, on GPS-guided emergency communications, on systems that a geomagnetic storm can quietly degrade at the worst possible moment. Now the focus shifts to what comes next for the broader Pacific region. Typhoon season in the Western Pacific officially runs from roughly May through November. Jangmi, the sixth named storm of 2026, arrived unusually early in the season. sea surface temperatures in the western Pacific have been running above historical averages for much of 2025 and into 2026, a pattern documented by NOAA's Pacific Marine Environmental Laboratory and consistent with what climate scientists at NASA's Climate Monitoring Division describe as an ongoing shift in the thermal gradient that feeds tropical cyclone development. What that means in practical terms is that typhoon season is not just beginning. It is beginning in an environment more favorable to rapid intensification than the environment that existed 20 or 30 years ago. Jangmi itself underwent periods of rapid intensification. A storm that was producing 7,000 home power outages on June 1st was producing 60,000 home power outages by June 3rd. That escalation happened in less than 48 hours. The same waters that fed Jangmi are still warm. The same atmospheric steering pattern that drove it northeast toward Honshu is still present. And this is only the sixth named storm of a season that historically peaks between August and October. Most people are missing this. The timing of Jangmi was not just early, it was unprecedented in one specific way. The Japan Meteorological Agency's new 5-level disaster warning system, only introduced in May 2026, was forced to issue a level 5 alert, its highest possible rating, for the Koza River in Wakayama, during the very first typhoon of the season after the new system launched. A system designed to better communicate extreme danger was immediately tested by exactly the kind of event it was built to handle. Japan's meteorologists got the warning right. But the warning only works if people act on it. And Tokyo's level 4 alert, issued for the first time in the city's history under this new system, revealed a troubling pattern that officials openly addressed in their post-storm briefings. More than 6 million people were under evacuation orders, but behavioral surveys showed that many residents chose not to leave their homes despite the official warnings. This is not uniquely Japanese. It is universal. People make calculations. They remember the last storm that looked bad on paper but was manageable in practice. They weigh the disruption of leaving against the risk of staying, and sometimes they are right, and sometimes they are not. The Koza River in Wakayama rose fast enough that authorities upgraded from normal flood alert to level 5 emergency in a matter of hours. Not days. Hours. But here's the problem that emerges when you look at the larger picture over Japan this week. The country did not just face one extraordinary event. It faced two, a typhoon at sea level and a geomagnetic storm from outer space, within 72 hours of each other, and both events carry tail risks that are still unresolved tonight. For Jangmi, the damage assessment is ongoing. As of late June 5th, reports of landslides, flooded infrastructure, and rail track damage were still coming in from multiple prefectures. The Izuku line in Shizuoka has no timeline yet for reopening after mud and debris covered its tracks near Maihama Kaigan Station. The Koza River section of road along the riverbank in Wakayama was flooded, and prefecture officials confirmed damage but noted it was still being documented. The full toll on agriculture, on the rice paddies and farming communities of Shizuoka, Wakayama, Mii, and Aichi will not be known for weeks. For the geomagnetic storm, the picture is equally unresolved. The Cannibal CME arrived at Earth's magnetosphere on the morning of June 5th. KP values rose. Space weather observers noted that solar wind speed and proton density measurements were still in flux as the bulk of the CME's structure continued to interact with Earth's magnetic field. Scientists openly stated that the trailing portions of the merged ejectocloud, the slower-moving material swept up by the Cannibal, could produce secondary surges in KP activity as it arrives in waves. The June 11th to 12th active window is now approaching, not receding. An AR4455 still showing a beta-gamma-delta configuration in images captured as recently as June 4th, had not rotated beyond the solar limb as of the time this script was finalized. What happened in Japan this week is not a closed chapter. It is an open one. Consider the intersection of these events for a single family in Wakayama. They woke at 4 in the morning to a level 5 flood emergency warning on June 3rd. Their power went out. Their GPS-dependent car navigation system gave them degraded directions. Their local emergency radio station used high-frequency communications that were intermittently disrupted by the early geomagnetic storm activity already building in the upper atmosphere. They had to decide, in darkness, without full information, in wind and rain, whether to stay or leave. They made a choice. And in the places along the Koza River where floodwater rose into homes before dawn, that choice had consequences. Multiply that family by 1, 6 million in the evacuation zones. Multiply it across Okinawa, Kagoshima, Wakayama, Mie, Shizuoka, Kanagawa, Tokyo, Chiba, Hyogo, every prefecture that this storm touched on its path from the subtropical Pacific to the waters east of Narita. And then layer over that entire map the invisible pressure of a sun that has been erupting with unusual violence from a region that scientists are still watching with concern. This is what double exposure looks like in the age of modern climate and space weather interaction. Two systems, neither one aware of the other, neither one coordinating with the other, arriving together at the same island nation with a population of 125 million people. A power grid stretched thin by storm damage, a GPS-dependent emergency response infrastructure operating under geomagnetic stress, and a typhoon season that is only just beginning. The next typhoon forming in the western Pacific right now will find the same warm water that fed Jangmi. AR4455 is still rotating. The June 11th geomagnetic activity window is less than 1 week away. The atmosphere above Japan has not settled, the magnetosphere above Japan has not settled, and the communities still cleaning mud from the floors of homes along the Koza River, still repairing train tracks in Shizuoka, still waiting for power restoration in pockets of Okinawa and Kagoshima. Those communities do not have the luxury of waiting for certainty. What is unfolding right now is a reminder that the Earth does not operate in isolated categories. Space weather is not separate from typhoon season. Geomagnetic storms do not wait for flood warnings to be lifted before arriving. A Cannibal CME does not consult a meteorological calendar. And the sun, currently at the maximum of solar cycle 25, with sunspot region AR4455 still churning in its beta-gamma-delta configuration, is not finished. Japan's meteorologists got the level 5 warning right. The space weather forecasters got the G3 watch right. Both systems did exactly what they were designed to do. The question now, the question that the next 72 hours will begin to answer, is what happens when the second wave of CME material arrives, when the June 11th window opens, and when the next tropical system organizes over water temperatures that are already primed for rapid intensification. The sky over Japan is clearing, the typhoon has moved on, the KP index is fluctuating, the engineers are assessing what the storm left behind, the river levels are dropping, but AR4455 is still there, the sun is still at its peak, the season is still early, and the systems that converged over Japan this week have not finished writing their story.